All right, we're going to do problem section 2.7, problem number 6. This one has this strange equation, and it says find all the points which are tangent to the line that are horizontal, which means a slope of 0, or vertical, which means it's an undefined slope. And it talks about using graphing utility. And here's how I would approach this one. So I'm going to go to Desmos, and I've already typed in the original equation. And let's take a look at it. Kind of a strange looking curve, isn't it? Whoop, zoom in a little bit there. A little bit more. Okay, so now where on this curve is there a horizontal asymptote? Well, it looks like there might be one in here. And one here and one here. I don't know. This looks like it goes up to me and drops slightly, or maybe just stays the same, but up a little bit. So there might be 3 different points there. But here for sure there's one right there. And there's one right there. And there's one right there. And right there. And so we need to know those y values for those horizontal places. And there's vertical ones. Look like there's one here, one here, one here, one here, one here, and one there. Okay? All right. So we need to know the slopes where it's 0 and where it's undefined. Well, if I take the derivative of this side, which I already have done, each one of those will have a dy dx. So I wrote the derivative of this. 2y to the third derivative is 6y squared. Derivative of y squared is 2y. And the derivative of this of y to the fifth is 5y to the fourth. And then to finish solving for dy dx, I would divide over here. This is the derivative of this part. Okay? So if I were to divide this over underneath this, I would have a numerator that's this expression, all in x, and a denominator that's all this, and it's an expression in y. To have a 0 slope, the numerator would have to be 0. Now in class, I factored this for you folks, but I can also just graph it, which I typed in that equation right here. And so I'm going to turn that equation on, and you notice that it crosses at, if I click on it, crosses at 0, 0, 0.50, and 1, 0. So those are the 3 zeros. So I wrote x equals 0, and there's that line, the y-axis, x equal a half, and x equal 1. I'm going to turn off that graph now, and now I have where the slope is going to be 0. There, 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 at that point, at that point, at that point, and at that point, that point, that point, and that point. So there are 1, 2, 3, 4, 5, 6, 7, 8 places where the tangent line is 0. And those points are, if I just click there, I can see it's 0, 1.624, and 1, 1.63. It's approximate. I can move around. It's not adjusting to being right on the curve, and I think it's because that equation is so nutso. Okay? But I can get a pretty good approximation of the answers. It looks like this one's right about there. This one's right there. This one's right there. And I can see those points. Okay? So there's all the horizontal asymptotes. Now I'm going to turn those off. I'm going to actually remove them and remove this equation, so I can now see I got that. Now this part of the derivative would go in the denominator, and it would be undefined slope if that was 0. So I'm going to graph x equal that, and that should be a sideways curve. So I'm going to turn that on, and you can see it goes over here, down, back, in here in the green. And it crosses right there, which is at 1.2345. This is that number rounded off. I'll put in the 4. Okay? And it crosses right there, which is 0. Crosses right there, which is negative 0.3785. So I'll change that to 85. And the last one is down here, negative 0.856. Okay. Now, I'm going to draw horizontal lines through those points. So I'm going to turn this one on, and I'm going to turn that one on, that one on, and that one on. And now I'm going to turn off this equation for the denominator because I've located where it was 0. And so where this crosses the curve is where there's a vertical tangent. And that point is basically 0.85 and 1.2345. And this one is that number. So there's 2 of the points where there's vertical tangents. There are vertical tangents right here. That's one of them. That's another one. That's another one. And that's another one. This one, it turns out there is no vertical tangents because it never hits the curve. We can zoom out, and you can see that it never hits the curve. The curve doesn't go there, at least according to Desmos. Now, maybe there's part of the curve that this didn't graph, but it doesn't look like there's any with that white line. So I can turn that one off. And so there's 1, 2, 3, 4, none there, none there. So I can turn that one off. And so 1, 2, 3, 4, 5, 6 of them. Okay? So that's an idea of how you could solve number 6.